Hello everyone, thank you for joining us. My name is Kosol Kiatreungwattana. I am a senior engineer at the National Renewable Energy Laboratory, NREL. NREL is one of the national labs of the U.S. Department of Energy. For today's webinar, I will be giving a presentation on the levelized cost of energy. And today's agenda, we will go through what is the levelized cost of energy and why is it important. And we're going to look at the application of the LCOE. The second one, and how to evaluate the LCOE. We're going to looking at the key parameters and what the sensitivity of those parameters to the LCOE. And the last one, we're going to look at the example of the results and the application. Particularly, we're going to show you the transparent cost database that includes the cost of the renewable energy project or like the electricity generation technology that will include all the costs of the LCOE, the capital cost, and the O&M cost, operation and maintenance cost. What is the LCOE and why is it important? LCOE, or levelized cost of energy, is the measure of lifetime cost divided by energy production. It's an economic assessment of the net present value of the unit cost of electricity. A common unit of this is the dollars or the currency divided by the kilowatt hour or megawatt hours if the scale is bigger. LCOE is used to compare different electricity generation technology on a consistent basis. Most common electricity generation technology are from the renewable energy, such as solar, wind, biomass, geothermal, or in non-renewable such as a conventional by coal, natural gas, or nuclear. Why LCOE is important? From this chart, you can see most common term that people would talk about any project. What is the cost? What's the install cost? What's the capital cost of the project? And on this chart, we're showing that on the scale for PV project or various type of size, the wind technology and the biomass, you can see like what the average cost. However, these costs, the capital cost, does not provide you a complete picture with any electricity generation technology are cost competitive. That's why the LCOE is a good indicator to compare projects by projects. The next slide on the application of the LCOE. The LCOE is one of the most commonly used metrics for assessing the financial viability of the energy projects. It's a measure value across the longer term, showing project life cycle cost means like we're looking at not just only the capital cost, basically all the costs associated of the whole project life. It highlights the opportunity to develop future projects. So once you're comparing the LCOE of particular technology, you will start seeing that there's a potential to develop or looking at further in terms of future investment on particular technology. It will help make informed decisions to pursue projects on the economic basis. And when we compare to utility, so I'm going to show you the common term that the industry has been using when you're comparing this LCOE with the utility rates. There's a term called grid parity. Grid parity is the break-even point when LCOE of the alternative energy is less than or equal to a price of purchasing electricity from the grid. It will help inform a decision to proceed to a future project development. On this chart, you can see that the electricity that produced by solar energy, it's showing that by the, with the time, the cost will go down and go down. You can see that, when we compare with the utility cost, whether it's going to be a common, I'm just give you a number, for example, 10 cents per kilowatt hour. So once like the solar electricity, the cost will come down and then cross that section. That's where it's showing that, oh, it's potentially, you can compete. Technically, you can compete with the cost of the electricity from the grid. So it's really, really popular metrics when we're looking at, when we evaluate particular projects. This is next slide. It's going to showing the grid parity on the solar energy. This is for the United States. You can see that in many areas of U.S., LCOE of solar PV actually is lower than the electricity rates. So it's showing that the economic feasibility of the solar PV in many areas in U.S. And from the GTM research in 2016, it's showing that 20 United States are currently at the grid parity. And by 2020, another 42 states are expected to reach that milestone as well, which is we're talking about under the business as usual conditions. So the more detail of this study you can see from the link below. How to evaluate LCOE? I'll give you example as the a simple. The LCOE is basically a total life cycle cost of particular project divided by a total lifetime energy production. On the graphic below, it's showing a cash flow of the project. You're starting with upfront, a high upfront system cost, and then there might be some any incentives that are applicable, from the bottom of the chart. And you start seeing the cost of the project on the operation and maintenance, any variable or fixed operation and maintenance for the project. And the project itself for the solar will produce electricity, which is have a cost value of the whole project. So once we put everything in the calculation, so here's like another graphic that's showing, adding this cost, this is kind of scenarios, and then come out at the end, the LCOE from this calculation is at 12.5 cents per kilowatt hour. So with a little bit more on like mathematics, but don't freak out because we have a tool that will help the projects to help to doing analysis on this LCOE. So on the upper term, those are the terms that and the parameters that we're gonna go talk about in the next slide on these those terms and how important of those terms. And on the Excel spreadsheet, so it's this is the LCOE calculator that will be going into a detail during the workshop. LCOE key parameters, starting with the investment cost. A common is a cost, whether it's going to be the total investment cost or the cost by the system capacity. The project financing and incentives, sometimes whether it could be a fixed capacity-based incentive or a production-based incentive. Discount rate is an interest rate that basically discounts the whole cash flow to a net present value of the project. So it's part of the calculation that we use the discount rate. We will discuss like what would be an appropriate discount rate during the workshop. Fixed operation of the maintenance or operation and maintenance, or O&M. It's usually it's a cost, and the common is the cost per system capacity. So it's $1 per kilowatt hour. That's a common term. Variable O&M cost, normally, commonly, it's $1 per production, which is $1 per kilowatt hour. It's an incremental O&M cost that incur upon increasing the level of production. It includes minor unplanned maintenance, water usage, chemicals, ancillary energy use, or ash disposal costs. This is, for example, with the conventional generation. The next parameter is the capital capacity factor, or another term is called utilization. Basically, it's the percentage of the how much the electricity generation technology can produce over the full capacity, technically. The heat rate for any thermal generation technologies will have a heat rate, and then what kind of conversion factor that will convert those heat rate to the another unit that will be neutral for the whole calculation. The fuel cost, whether it's going to be $1 per liter, $1 per ton of biomass, or any like fuel cost, that will be, most of the renewable energy projects have zero fuel cost, but biomass, whether because of the most of the time it's a tons of, like, whether it's gonna be wood chips or any agricultural byproducts that will be a raw material for those biomass technology. System degradation rate for the system once over the lifetime, starting from like produce electricity at the whether it's gonna be at rated or pretty high on the efficiency, but over the lifetime it will produce less and less electricity over the lifetime. So we'll estimate the percentage of this degradation and then apply to this calculation. And the last one, the annual electricity generation, basically whether we have the data, that the actual data, or it would be a model based, will estimate the annual electricity generation and the value of this electricity that this technology produce. On this slide, we'll show you that the sensitivity, and this is just only an example of for the solar sensitivity, particularly looking at the system cost. This one we will see that this is for the data for United States, and this is the model that we're looking at in 2014. That at the system cost, at you can see that on this graph showing most LCOE are basically over 50% of the break-even. Means like the cost is still high, it's pretty high. Just only you can see that the California, which is on the green color, that showing that because of the cost of electricity in California is relatively high. So $4 it's basically still okay, still like competitive. So on the chart, on the graphic on the right hand side, so once like we will simulate the system cost at $2 per watt, we can see that most LCOE are slightly above break even, means like it's starting getting very, very cost competitive to the grid. The next slide, how about like at $1 per watt? $1 per watt, we can see that definitely most LCOE are below 25 to 50% below of the break even. Pretty much at $1 per watt, the solar PV are very competitive almost everywhere in United States. So when we're looking at this, you can see that the system cost is very, very, very important and make it the LCOE very sensitive to the system cost. So with the last graphic on the right-hand side, so we run the break-even. So in the United States, so what's the break-even of the system cost will reach the grid parity? We can see that with the utilities in the United States, at the different states, we'll have a different utility rate. But pretty much it will showing that the break-even is around $1 to $3 per watt, with an exception of the California that you can see that even like $5 or even over $5 per watt in 2014, it can be very cost competitive compared to the utility rate. How about other parameters? There's a study that looking at the LCOE sensitivity of other parameters. Here's a summary of that study. A higher discount rate almost always results in a higher LCOE. Means like, you know, the discount rate is definitely it's a very important how much you discount all this cash flow to the project. So means like, you know, when we looking into the discount rate, it's gotta be appropriate and then reasonable. So for your projects, we will discuss what would be the a reasonable discount rate that we will be used for the LCOE analysis. The system performance, a lot of the time you can see that the system degradation is also is a significant contributor to the LCOE, but a lot of the time it can be minimized, you know, as the manufacturer will improve their process to eliminate number of module failures prematurely. This is just for example, or the degradation, instead of like, you know, a certain percentage, it might be a lot lower when the technology progress in the future. The solar insulation or the solar radiation, it appears to have a relatively small correlation with the LCOE. By all means, it means that, you know, when you're looking at some area that have a lot of sunshine, and then there might be some area that have a slightly less sunshine, actually it has pretty low impact to the LCOE from this study. On this example, also another study that looking at the LCOE sensitivity of the wind technology. Here are the two summaries from that study. The initial capital cost, you know, basically the system cost that we just talked about it, and then the capacity factor are two critical drivers of the LCOE for the wind technology. Discount rate and annual operating costs are also significant contributors. So again, I encourage that to looking at if you want to looking at the detail of this study, there's a source and then the reference at the bottom to check it out. The next section, we're going to look at the example of the results and the application of the LCOE. On this chart, it's showing that the example of the LCOE of the energy technology in United States. So this will include both the renewable energy and non-renewable energy technology. And you can see from the y-axis, that's where the unit that which is the dollar per kilowatt hour, and then on the x axis will showing that that's the technologies, and those numbers are basically showing the number of data that being calculated for these calculations. So in this example, you can see that for the solar photovoltaics, we have a lot of data, more data, and then have a wide range of the LCOE from that calculation. So how about what's the trend of the LCOE of the renewable energy technology? You can see that most of the renewable energy technology, the LCOE goes down as the time progressing due to the cost of the technologies, the capital cost of the technology dropped significantly from 2010 to 2016, particularly if you're looking at the solar photovoltaic category. And then interesting that from this study showing that on the geothermal and the hydro, the cost, the LCOE is higher when the time are progressing. On the next slide, it's also showing the previous study of the LCOE analysis that's been done for the ASEAN countries, and it's showing that these three renewable energy technologies from the hydro, biomass, and then the different scale of the solar photovoltaics projects. And then on the right-hand side, show the various LCOE from those countries. So we can see that the again, once I encourage the next step is to compare this LCOE with the utility rates that you can pinpoint that which projects will be worth pursuing in the next step, such as the feasibility study or help screening for your future projects. And on this one, when we talk about the transparent cost database, so the transparent cost database, which is the part of this project that it will include, it's a database that from this study we were looking at help calculating the LCOE for various type of the technologies. We'll track all those capital costs and O&M costs, operation and maintenance costs, and then what would be the capacity factor for particular technology that should be used, or what the actual capital capacity factor from particular technology. What's the application of the transparent cost database? Is it a database that it can be viewed and compare with other published estimates? It includes the technology that from both from the future and from the current projects that you will use, and then compare what kind of use is for the future. Let's say that you think about that you wanna develop a solar project or a wind project or the biomass project. These costs will help doing the economic in the future, and for any developer can use this cost data as a reference. For additional resource of this study, I encourage to check out this both from the previous webinar and the workshop that we have on the Renewable Energy Data Explorer on the user guide is upcoming, coming soon. So we'll have a user guide for these two. And on the bottom, on the levelized cost of energy analysis. So those are good, useful resources. Also, please also check on the tutorial series that we have from the previous webinar and workshop. Thank you very much, and have a good day.